Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review what we went through in week 11. So we went through radians and angles of any magnitude, i.e. the unit circle. So let's start with radians. So let's say I have a circle here whose radius is 1. Now, if I draw this sector here such that this arc length is also 1, I'm going to let this angle in here be theta. So what fraction of a circle is this arc here? So the full circle, its circumference would be 2 pi times r, which is 1. The full circumference of this circle is 2 pi. So this arc here represents 1 over 2 pi, which is about 15.9% of the circle. So what would this angle be? Well, because this is about 15.91% of the circle, this angle will be 15.91% of a full circle. Our full circle is 360 degrees. So this here, this angle in degrees, theta, will be 1 over 2 pi times 360, or just simplifying that, it will be 180 over pi degrees. So 180 over pi is about 57.3 degrees. So that is the angle subtended here. That is the value of theta. So we're going to define this angle as 1 radian. So, radian has like a C symbol, C-looking symbol there. 1 radian is the angle subtended by an arc of length 1 when the radius is also 1. So 1 radian is about 57.3 degrees. So a radian is just another way to measure angles. We do need this, unfortunately, because when you do things like calculus, things don't work unless the angle is in radians. So 1 radian is 180 over pi degrees. So that means there's a very simple conversion between radians and degrees. So to go from radians to degrees from here to here, you just times by 180 over pi. So obviously to go from degrees to radians, you do the opposite. You times by pi over 180. So radians are just a different way to measure angles. So unfortunately, this means for you, you're going to need to be really conscious of your calculator. Sometimes we're going to do calculations involving radians, sometimes degrees. Your calculator needs to be in the right mode. So some simple conversions, 90 degrees. If I want to convert that to radians, I just go 90 times pi over 180. Of course, 90 over 180 is just a half. So 90 degrees is pi over 2 radians. So they're the exact same angle. So if I have something like pi over 6 and I want to change that to degrees, all I do is times it by 180 over pi. So the pi's cancel each other out, and 180 divided by 6 is just 30. So pi over 6 radians is the same as 30 degrees. Make sure you can convert between the two. Now let's look at arc length and sector area. So let's say I want to find this arc length here. X is the arc length, R is the radius. So I know the full circumference of the circle is 2 pi r. So the way that we're used to finding arc length is we take the full circumference and multiply by the fraction of the circle that we have. However, though, 360 degrees is the same as 2 pi radians. So if I put the angle not in degrees but in radians, I have this formula here. So this makes it really simple because the 2 pi's can cancel each other out. So the arc length is just r, radius, times theta, where theta is in radians, which makes it really simple. So let's say that the angle here, theta, was pi over 3 radians. So pi over 3 radians is 60 degrees, and we're going to let r be 4 units. The arc length then would just be r, radius, times theta in radians, pi over 3. And that gives us about 4.189 units, and that would be the arc length. All right, so sector area, there's another simple formula. I won't go about proving that. It's just half r squared theta. So once again, theta needs to be in radians for you to use this. So what we're going to do is actually quite a difficult question. We're going to find this area here. So sector means like a slice out of the circle. So this whole thing is a sector. So what I'm going to do to find this area here is find the area of the sector, and I'm going to subtract the area of the triangle. So here, I need to know the radius of this circle. Both of these would be the same. So this angle here is 5 pi over 9 radians. Because the triangle's isosceles, these two angles will be the same. So all angles in a triangle add up to pi radians, because pi is 180 degrees. Now, it may be easier for you to convert this into degrees to find these two angles. So 5 pi over 9 radians, to get that into degrees, you just times by 180 over pi, you get 100 degrees. This angle here is 100 degrees. So what that means is that this angle here would be 40 degrees, or 2 pi over 9 radians. So why am I interested in that angle there? Well, I'm going to use the sine rule now to find what r is. So using the sine rule, I have r over sine. Now you can do this calculation in degrees or radians. R over sine of its angle equals 12 over, now because I put this in degrees, I have to put that in degrees, 12 over sine 100. So you know how to do this. All I do is take this times by sine 40, and that gives me r. So doing that, I get r is about 7.832. So please make sure when you're doing this calculation here, your calculator needs to be in degrees. So now I've found r, I can easily find the area of this triangle and the area of the sector. So I'm going to call A sub S here the area of the sector. So it's a half times r, which we just found out, half times r squared, and then we times by theta, but theta must be in radians. So this is what we get for the area of the sector. So when I find my answer here, if I'm going to round it, I want to round it to a lot of decimal places. So I get about 53.53551, and that'll be centimeters squared. So I've used a lot of decimal places here. So in my calculator, I didn't actually put this, by the way. I actually put the exact answer. So you leave this exact answer on your calculator, times it by half, times it by 5 pi over 9, and then you get this answer here. So that's the area of the sector. So how are we going to find the area of the triangle? Well, we can just use half AB sine theta, because we know side, and angle between. So finding the area of the triangle, it's like half r squared, but sine theta rather than just theta. So when I'm putting sine of this in my calculator must be in radians. So I got the area 30.2076 centimeters squared. So, of course, that means the shaded area is just this minus this. It's about 23.33 centimeters squared. That's the area there using sectors and triangles. All right, let's now move on to the unit circle. So this here is the unit circle. It is a circle of radius 1 in the Cartesian plane. Its center is the origin. So when we refer to angles theta, we're referring to the angle made with the positive x-axis. So I apologize. I know it's difficult because this is different to bearings. With bearings, we went 0, 90, 180, 270, 360. So when we're dealing with the unit circle, we start at the positive x-axis and we go anti-clockwise, 0, 90, 180, 270. So here the red numbers are in degrees and their corresponding measurements in radians are in blue. So let's say I draw a triangle here that's right angled. This distance here is whatever the x coordinate is at this point. This distance here is the y coordinate of this point. So I have sine theta is equal to opposite over hypotenuse. I can use SOHCAHTOA because this is just a right angled triangle. So sine theta equals y over 1. So sine theta is whatever the y coordinate is. Cos theta, similarly is x over 1, whatever the x coordinate is, and tan theta is opposite over adjacent, y over x, or sine over cos. So what does that actually mean? Well, let's now look at some angles that are more than 90 degrees, which we haven't really done yet. So let's say I want to find the sine, cos, and tan values of 120 degrees. So what I need to do is I need to make this angle here 120 degrees. So I'll draw a line there. So if the angle from here to here is 120 degrees, this angle there must be 60 degrees because that makes up 180. So I'll draw my little triangle there. So if this angle is 60 degrees, how can I find sine, cos, and tan? Well, what I do is I find an equivalent ratio in the first quadrant. So if I make this angle here 60 degrees, these two triangles will be congruent. So this distance and this distance will be the same. This distance and this distance, they'll all be the same. So I know from my table up here, sine theta is root 3 on 2, sine 60 is root 3 on 2, and cos 60 is a half. So it turns out if you make this angle here 60 degrees, this point here will be x coordinate will be cos of 60, which is a half, and the y coordinate will be sine of 60, which is root 3 on 2. So what would this point here be? Well, this point here would be the same, except over here, the x values are negative. So what it would actually be is minus a half for the x value. The y value is still positive. So what we have here, sine of 60 was root 3 on 2. Remember, sine is just the y value. So sine of 120 is the y value. It's also root 3 on 2. Cos of 60 is going to be the x value. Cos is the x value. Cos of 60 is minus a half. And tan of 60 is y over x, which is actually just minus root 3. So that's how we can find sine, cos, and tan values of angles more than 90 degrees. We need to find an equivalent one in the first quadrant. So to help us with this, we need to know our exact values. So you might have noticed here, sine is positive, but the other two are negative, because in this quadrant, x value is negative, so cos will be negative, and y values in this quadrant are positive, so sine will be positive. So tan will always be a positive over a negative, so it will be a negative. So in this quadrant, then only sine is positive. In this quadrant down here, the x value and the y values are both negative, so sine and cos are both negative, but tan is negative over negative. It will be positive. So only tan is positive in this third quadrant. In the fourth quadrant, only cos is positive, but in this first quadrant, everything is positive. So remember this acronym as like all students take calculus. So start here in the first quadrant, because we're looking at the positive x-axis and going anti-clockwise. All are positive in the first quadrant. Sine is positive. Only sine is positive in the second quadrant. Only tan is positive in the third quadrant. Only cos is positive in the fourth quadrant. So let's now fill out the rest of this table for 0 and 90 degrees. 0 degrees here. So at this point here, this is the point 1, 0. Cos is the x value, which is 1. Sine is the y value. Divided by 1 is 0. So sine 0 is 0, cos 0 is 1, tan 0 is 0. What about at 90 degrees? Well, what happens here? X coordinate is 0, the y coordinate is 1. So sine is the y coordinate, which is 1. Sine 90 is 1. Cos 90 is 0. And what about tan 90? Well, that would be 1 divided by 0, which you can't do. 90 is actually undefined. Can't take the tan of 90 degrees. So remember, 90 degrees is just pi on 2 radians. What that means is sine pi on 2 radians is 1. Cos pi on 2 radians is 0. Tan pi on 2 radians is undefined. So we'll do one more example where these exact values can be calculated. So let's say I wanted to calculate the value of cos of 5 pi on 3. So you might find it easier to work in degrees and convert this to degrees. So if I convert it to degrees, timesing by 180 on pi, I get 300 degrees. So you can use either of these. So what would be the value of cos 300? Well, what we need to do is equivalent ratio in the first quadrant. So it is 360 all the way around here. So the acute angle would be 60. So why is that? If I start at the positive x-axis, go anti-clockwise all the way to 300 degrees, what we have left is 60 degrees because 360 is a full circle. So cos of 300 degrees, cos of this angle here, will be the same as cos of 60. So it will be the same as cos of 60 degrees because this triangle here and this triangle here would be the same. So cos of 60 was a half. Cos of 300 is also a half. I know that cos is positive in this quadrant. But on the other hand, if I wanted to find sine 5 pi on 3 or sine of 300 degrees, well, what would be the difference between sine of 300 and sine 60? Well, this triangle here is still the same there, but the thing is the y value in this triangle is negative. The y value at that point would be negative. This would be the point a half. X is still positive, but y is negative. So sine of 300 is the same as sine of 60, but we know that sine is actually negative in this quadrant. In this fourth quadrant, only cos is positive. So sine 300 is actually minus sine of 60 degrees. It would be minus root 3 on 2. So to find any angles of magnitude, what you have to do is find the equivalent triangle, the equivalent angle in the first quadrant, and use your knowledge of exact values. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.